All right, so we'll have a short break after this presentation. Our next presenter is a student that I've known for a minute or two. Was in my climate change studies class. I had the opportunity to work with Cassie when she was an undergraduate and on her thesis, undergraduate thesis as well, and really enjoyed having her in the program, and just the level of quick generative thinking and the upside potential in the long run to make big change in a socially responsible and ethical way. I see in the long term Cassie likely having a very big impact. And project title is How Are the Connections Between Pesticide Use, Climate Change, and Ecosystem Health Incorporated into Policy and Regulation? A case study of almond presentation in Fresno, California. Cassie, the floor is yours.
Close this out. All right, well, hello everyone, and thank you so much for coming to listen to our talks today. So in my project, I asked the question, how are the impacts of climate change on pesticide use incorporated into policy and regulation, looking specifically at a case study of almond production in Fresno, California. So for some background, pesticides are used globally to control pressure from pests. They can come in the form of fungicides, herbicides, or insecticides, and the production and application of pesticides results in the release of greenhouse gas emissions. So the motivation for this project is that climate change is expected to increase pest pressures, so increased pesticide use will be needed. And pesticide use has adverse impacts on ecosystems that can be amplified in the context of climate change. Neonicotinoids and glyphosate are the main focus of this study because neonicotinoids have major impacts on bees and because glyphosate is the most widely used pesticide in the world. Almond production in Fresno, California was selected as it is the county with the largest share of pesticide use in California. So for the methods of this study, a literature search was conducted using Google Scholar to search for articles to inform on the connections between pesticide use, climate change, and ecosystem health. For the data analysis, trends were established for pesticide use in California and Fresno County, and the correlation between pesticide use, temperature, precipitation, and honeybee colonies' health were analyzed. For the policy analysis, the entirety of California's pesticide laws and regulations were read and analyzed to determine the type and extent of climate and environmental considerations present. 6 interviews were also conducted with representatives from Pesticide Action Network, Californians for Pesticide Reform, Beyond Pesticides, Center for Biological Diversity, and the Center for Environmental Health to further inform on the implications of these findings. So climate change is expected to cause insect populations to grow and change in distribution, crop resilience to decrease, resistance of weeds to increase, and degradation of pesticides to be enhanced, overall decreasing the effectiveness or efficacy of pesticides. As crop yields are affected, more pesticide use will be required to address increasing pest pressures. This increase in pesticide use is expected to cause declines in soil biodiversity and quality, declines in pollinator populations, increases in greenhouse gas emissions, and increases in harm to human health. These will all lead to declines in ecosystem health, exacerbation of climate change impacts, and decreased carbon sequestration that will all ultimately lead to more pesticide use being required, which will cause a repeat of these numerous impacts and their cascading effects. The literature review also yielded that both glyphosate and neonicotinoids have significant adverse impacts on both honeybees and soil ecosystems. So in California, the total pounds of pesticide use was found to be increasing over time until the year 2020, in which there was a significant downturn in overall use, which contradicts what I expected to observe. In Fresno County, the county with the largest share of pesticide use in California, the trend mirrored that of statewide pesticide use. A machine learning model was employed to identify the 95% confidence interval for the correlation trend observed. All data points fell within the 95% confidence interval, and pesticide use was found to increase as precipitation increased, up until a saturation point around 120% of average precipitation. Overall, it was able to be concluded that pesticide use correlates with precipitation with 95% confidence. So the total number of acres used for almond production in Fresno has been increasing at a relatively constant rate over time. But despite this, glyphosate use on almonds in Fresno County was found to be increasing until 2020, in which there was a downturn in pesticide use, after which it continued to decrease, again contradicting my hypothesis of pesticide use increasing due to climate change. The amount of glyphosate used per acre of almond production in Fresno County followed the same trend. So in California, the number of honeybee colonies present greatly fluctuates each season because of the widespread practice of renting honeybee colonies from across the country for crop pollination. The season with the greatest loss of honeybee colonies in California is January to March, which happens to coincide with the season in which bees are utilized for almond crops, which is late January to early March. The percent of colonies lost per year increased until 2019, after which the number of colonies lost has decreased at a significant rate. A significant correlation was identified between the percent of honeybee colonies lost and the total amount of pesticide use in California. With a strong p-value of 0.02, indicating a high level of statistical significance, the percent of colonies lost was found to be increasing as pesticide use increased. This indicated that increased pesticide use may be having a significant impact in the observed decline of honeybee populations. Now, looking at the results of the policy analysis, environmental data requirements only included the potential for environmental damage and toxicity to aquatic biota, and are mainly focused around the human health impacts of pesticides. Data requirements also appear to be less specific when detailing analyses of environmental impacts, while those for assessing human impacts are much more detailed. If a pesticide may be likely to contact commercial apiaries or pollinating bees, then an analysis of acute chronic toxicity to bees is required for that pesticide. But this is the only species mentioned directly in the data requirements. Any additional data detailing contaminants present in products, environmental effects, or the effects of pesticide mixtures are not included unless the California Department of Pesticide Regulation, or CDPR, requests this data. In addition, manufacturers of pesticides are often responsible for providing the required data, so important peer-reviewed studies may be overlooked. In one section of the regulations, it details how some pesticides can be declared to be critical to agricultural production. If the loss of a particular active ingredient or pesticide could prevent the commercial production of a crop, result in the introduction or dissemination of a new pest, cause a health hazard to livestock, cause hardship on California's agricultural industry, or if no other effective replacement is available to be used for the same uses, then that pesticide or active ingredient is considered to be critical for agricultural production. The lack of specificity around the meanings of multiple terms within this section have the potential to allow regulators to interpret this section as they please and declare a pesticide or active ingredient to be critical despite it not meeting the requirements, which could be detrimental as pesticides with adverse effects may be approved for this reason. Some terms that lack specificity in this section include could prevent, health hazard, and hardship. These terms could be interpreted in many different ways depending on the goals of the regulator. In Chapter 2, Subchapter 1, Article 6 of the Laws and Regulations, the environment is defined as the total human surroundings, physical and biological, natural and artificial, including air, water, soil, plants, wildlife, and other ecological factors affecting the growth, development, and safety of people and other living organisms. Although this definition is comprehensive and is included for the purposes of this section, there is no definition of environment included in the CDPR's glossary of terms listed in the first section of laws and regulations. This is definitely interesting as although it may be argued the word environment does not need to be defined due to its simplicity and universal use, other words in the glossary are included that are much less simple and require much less explanation, such as the word person. Within the glossary of terms, there are some definitions relating to the environment, but these only include aquatic habitat and groundwater protection area related terms. However, protecting water quality and fisheries production may be the main motivation behind prioritizing these terms rather than for the sake of protecting ecosystems. Chapter 4 of the Laws and Regulations is focused on environmental protection. This chapter is broken into 5 subchapters: 1, groundwater; 2, air; 3, aquatic and marine environments; 5, surface water; and 6, pollinator protection. Yes, you heard me correctly. Subchapter 4 of the environmental protection section is missing in the online regulations, and it is unknown what this 4th subchapter would have covered if it weren't present. And so if you Command F to search for a word on the regulations, you will not find climate change, greenhouse gas emissions, or soil health, as none of these are mentioned. Subchapter 6 details regulations for the protection of pollinators, and this is the only section of the laws and regulations that focuses on protecting a particular species, likely due to the irreplaceable services that pollinators provide for ecosystems and agricultural production. Neonicotinoids received their own dedicated section in this subchapter due to their acute and chronic toxicity to bees. And this section is very detailed and includes allowed amounts and application types for using neonicotinoids specific to each different type of crop, which should be effective in protecting bees from this chemical. So looking now at interview results, as shown in trends, the amount of glyphosate applied per acre decreased despite the fact that weed resistance to herbicides is increasing due to climate change. So various cancer lawsuits have been brought against Bayer, the producer of Roundup, which is the main glyphosate-driven herbicide, and these may have motivated Bayer to begin adopting alternative active ingredients. Newly developed alternatives may also be more effective at lower concentrations due to their toxicity loading, which would also explain the decrease in overall pounds of pesticide use that was observed. All interviewees with expertise on the subject also mentioned that massive bee die-offs have been observed within the last couple of years. The American Beekeeping Federation and others produced a report in February 2025 reporting that beekeepers in the US have seen 70 to 100% of their colonies collapse over the past 12 months. The causes of these declines are currently being investigated, and I wonder if pesticides will be identified as a contributing factor, and if they are, what would this mean for regulations? Interviewees argued that the data requirements for pesticide registration are focused around human impacts rather than environmental impacts as well. For instance, Apis mellifera, the most widespread species of honeybee, is often utilized as a model organism in tests to determine the effects of a particular species on bees. This may be problematic as different species, even within the same family, can experience different effects when exposed to a pesticide. As a result, the effects of a given pesticide can vary greatly from those exhibited in the model organism that is utilized in the study, causing adverse effects to be overlooked. Interviewees also agreed that inert ingredients, chemical mixtures, and residential uses were overlooked in the data requirements as well, which is detrimental as it means that additional adverse effects may be overlooked. As soil health data was unable to be located for the purpose of this project, interviewees were asked about their knowledge of soil health monitoring in the United States. Multiple interviewees agreed that the majority of soil health studies are conducted internationally and that many European countries conduct soil health monitoring using UN standards. The US does not currently carry out any comprehensive monitoring of soil health, so I recommend that the US adopt UN standards, as this will make it easier to create this new objective. The Center for Biological Diversity petitioned the EPA to use European standards in 2021, but the EPA has not yet decided whether to approve or deny this petition. One interviewee pointed out that climate change may also contribute further to enhancing the dispersal of pesticides as the frequency of wildfires increases and contributes to increased combustion of pesticides. Some inert ingredients have been found to significantly influence flammability and toxic gas generation in fires, and it was also found that hazardous gases are often emitted from the combustion of pesticides. Interviewees also agreed that manufacturers have a significant influence on the regulatory process in the US, as the regulatory agency must come into agreement with manufacturers about use restrictions, labeling requirements, and other regulations, in addition to the fact that manufacturers are the primary ones responsible for supplying the required data. Margaret Reeves from the Pesticide Action Network summarized the US pesticide regulatory process in a very straightforward and useful way. The US uses a risk-based system while Europe uses a hazard-based system. The European pesticide regulatory system identifies the potential for a pesticide to cause harm, while the risk assessments of the US system evaluate how likely it is that harm will occur and how severe the harm will be under specific exposure conditions. Because exposure is very difficult to evaluate, numerous assumptions must be utilized, causing the results of exposure studies to contain lots of uncertainty. Despite the fact that the US pesticide regulatory system has been centered around approving the use of effective pesticides for decades, the CDPR has recently released a roadmap for sustainable pest management in January 2023. Although this objective has not yet been codified into law, important goals are mentioned in the framework, such as the goal to eliminate priority pesticides by 2050. These priority pesticides will be identified by the CDPR and are labeled as high-risk pesticides that are hazardous or that are likely to cause significant human and/or ecological impacts. And this new development reflects a beneficial shift in the mentality of the CDPR and major progress towards changing the system to reduce the use of harmful pesticides. But it should be noted that implementation will be complex and require collaboration among many different parties in many different disciplines. So, overall, it was found that data requirements for pesticide registration in California are focused mainly on addressing human health impacts of pesticides, while environmental considerations are much less detailed. So significant adverse impacts may be overlooked. Inert ingredients, chemical mixtures, and residential uses of pesticides are also not addressed by regulations, again increasing the potential for significant adverse effects to be overlooked. California's pesticide regulations also do not include any mention of climate change, greenhouse gas emissions, or soil health, indicating that the connections between pesticide use and climate change are not being adequately considered. For these reasons, California's pesticide regulations would benefit from increased specificity of terms and increased consideration of the environmental and climate change impacts of pesticide use, as these will help ensure that pesticide use is sustainable in the context of climate change moving forward. So that is all for me, and thank you guys so much for listening. Any questions? You in the front.
Thank you, Cassie. That was a very good talk. My question is, when you look at California, there's a lot of diverse climates, even within the state. Have you found that to be significant in your research, or has that been addressed at all?
Yeah, so it's definitely very significant. And as far as had mentioned that climate change will affect the distribution of pests. So some southern pests might migrate northward. So instead, more northern states may have to deal with these pests that they've never dealt with before. And also even just, I did look at one study done in Europe, and just regionally looking at the different use of pesticides by region. It varies so much because of the soil type, the specific climate, precipitation, topography that affects the climate, kind of everything. So yeah, it really is, has to be managed on a regional basis because of just how variable all those different factors are and how important they all are to contributing to pesticide use. Yeah, I saw another one right there.
I was wondering, do you have an idea, as to why pesticide use decreased in 2020? Or you said it went against what you hypothesized. So do you have any idea why?
Yeah, so I think I touched on it a little bit. My interviewees were very helpful in adding, implications to what these findings mean. And so it was, many interviewees suggested that COVID-related supply chain changes were definitely impact the overall use of pesticides, probably influencing that initial decline. And then overall, when you have, newly developed pesticides, it's more cost-effective to have the pesticide be effective at lower concentrations. So you have to apply less pounds of pesticide to get the same effect. And so that would also explain just the total overall pounds of pesticide use decreasing over time as we get more efficient with how we, toxicity load our pesticides. And in addition to that, we also see, sorry, lost my train of thought there a little bit. Yeah, so can you repeat the question one more time so I can remember what I was going to say?
Why pesticide use decreased?
Oh, yeah, and also just, I was going to touch on glyphosate specifically also decreased as well. And I touched on it may be due to some of the, controversy around it being accused of causing, cancer in humans. And so these lawsuits have already motivated the, manufacturing company to switch to alternatives and start producing these. And in fact, I think glyphosate has already been removed from residential use products. So that way it's not present in homes and stuff like that. So really just seeing a shift in pesticides. And I think this happens really quite often where you see a shift to alternatives and, the data changes. And so it's really quite variable. Yeah. And any other questions? One right there, maybe.
Thank you for touching on this subject and giving it visibility. The waste stream for pesticides is our water. And I think you'll find that the regulations in stormwater cover pesticides, and your downward trend could be related to a new regulation in water.
Yeah, I could see, as far as, the overall pesticide pounds being applied, that could also be, due to potentially maybe stricter groundwater regulations and stuff like that, because they want to see less overall runoff, so less volume of pesticides running off into these ecosystems. But I would argue that the volume doesn't really matter, it's how toxic they are, this chemical is. So yeah, I think, and as I mentioned too, the regulations really focus specifically on aquatic habitats and groundwater over, other ecosystems. They definitely prioritize. And like I said, that kind of to me indicated that it was really for the sake of preserving water quality and for the sake of fisheries production rather than for the sake of just preserving these ecosystems, for themselves. Yeah. Yeah.